Hello and welcome to our new video. Today we discuss Taylor series, Taylor and Maclaurin series. So first I show you what are the Taylor series. If we have in this video you just see the Taylor series for one variable, not for two variables. So we consider if y is our function of fx, means on the x is the variable, so how we can expand in a convergence series for a small variation. If we one point is our x here, and if a small deviation it is x plus h and it is x, then what is the convergence series for fx plus h with Taylor? Say f of x plus h, f dash x, f dash means d by dx of fx. Function one time differentiate with respect to x plus h square by factorial to f double dash x. Double dash means two time differentiate function with respect to x, and so on. This is series, so we have infinite many terms. Again, if we consider any fixed point b, if we have for function this is a point and this is b point, if we want Taylor series for that b point, then if we can say a plus h, if this distance is h, then a plus h is equal to b. For that, what is our Taylor series? Then substitute a plus h, means here x is a plus h, so a plus h is b. So f of b is equal to, at the place of x, our a. So f of a plus h. H is what? H is b minus a. So b minus a f dash a plus b minus a whole square upon factorial to f double dash a, and so on. Now if we talk about the Taylor's theorem, so we can terminate this series up to nth term. So up to nth term, when we find out, means its nth term is b minus a to the power n upon factorial n plus f dash n times a, means we have to differentiate, plus we can say there is coming one remainder term, that is called n plus 1th term. So that we can also calculate for remainder terms for the next Taylor series. But now we discuss about how to find out up to n terms. So when you solve the problems, then you have given the function of single variable and you have to find out at least 3 or 4 terms for this Taylor series. So similarly, next is the Maclaurin theorem, or we can say Maclaurin series. Maclaurin series is one special case of Taylor. So what are the Maclaurins? I just show you. What are the Maclaurin series, or we can say it is Maclaurin theorem. So we have only nth term for function fx, where this is a single value function. So Maclaurin is, I just write fx equal to f of 0 plus x f dash of 0 plus x square upon factorial to f double dash of 0 plus so on x n upon factorial n f dash n of 0. This series is called Maclaurin. So when we compare this with Taylor, Taylor is f of x plus h. Clear? And this is the increasing power of h, means at the place if we put h equal to x and put x equal to 0 in Taylor series, or we can say if we have Taylor series in form of a, means I rewrite that Taylor series so you can better understand how to convert Taylor into Maclaurin. If we have series f of a plus h, so in terms of a plus h, Taylor is f of a plus h f
dash of a plus h square by factorial 2f double dash of a and so on. Now put a is equal to 0 and h equal to x. If we substitute, see, a is equal to 0 means 0 plus x. It means it becomes fx equal to f of a, f of 0, function value at 0 point plus h, at the h it x, x f dash of 0 plus x square by factorial 2 f double dash of 0, because a is everywhere 0. See, now you compare these both series, these are the same. So these called Maclaurin series, means Taylor series. Maclaurin series is a particular case of Taylor series. When we put point equal to 0 and h interval equal to x, our variable, then we will get our Maclaurin series. So now we see some problems how to expand our any given function of single variable with the help of Maclaurins and Taylor. So first I discuss some examples on Maclaurin, then we go for Taylor series. Okay. So now some problems. Some problems on Maclaurins. If very easy, if we have expand 10x equal to x plus 2 by 3 of x cube plus 2 by 15 of x5 and so on. Clear? So what is our question? We have to expand our function 10x. Means fx, we can say y is equal to 10x. Y or y means fx. Clear? So for Maclaurins, we need our derivative of the function at 0 point. So y dash means dy by dx. dy by dx of 10x is sec square x. Then third is y double dash. Y double dash means second order derivative of function, or we can say if we one time differentiate, then we will get y double dash. So derivative of sec square x is 2 sec x 10x. Okay. Derivative of sec x is 2 sec x 10x, and derivative of sec square x, one more time if we can, this is 2 of sec x, and derivative of sec x is sec x 10x. Sec x 10x. Clear? So what is our new derivative? 2 sec square x 10x. So I rewrite 2 sec square x and 10x. Now sec square x is y dash, y, you can say y dash, you can say y1, this is y2. If we write the notation properly, then we can substitute very easily. So if you put y1, y2, y3, that is more convenient. You should understand also y1 is first order derivative, y2 is second order derivative. At the place of dash, if you put 1, 2, 3, 4, then it's more easy. So this C, sec square x is our y1. So I put here y1, and 10x is our y. So we put here y, means our y2 gives the equation equal to 2y1 y. Clear? Again, if we want third order derivative is y3, means one more time we have to differentiate this. 2 is constant coming outside. Now we apply the product u into v rule. So for differentiation u into v rule, differentiate one function, other is as it is, then differentiate other function, one is as it is. So first we derivative of y1, when we derivative of y1 is y2. So y2 y as it is plus y1 as it is, derivative of y is again y1. So I put square here. Clear? So this is our third order derivative. Similarly, now when we reduce in y form, it's very easy to differentiate. See, now again if we want to derivate it, then what is this derivation? Derivation is y2 is y3, y as it is plus, then y2 as it is, derivative of y is y1. Similarly 2 of y1, like that. So this is y3y plus y3y plus y2 y1 plus 2y1 y. See, like that. Now here no point is there. Series in X means this is case or example of Maclaurins. Now you should write what is your Maclaurins. F of X is equal to f of 0 plus x, f dash of 0 plus x square by factorial 2, f double dash of 0, and so on. If we write this equation in terms of y, fx is our y, f0 means y at 0 point plus x, f dash means y1 at 0 point plus x square by factorial 2, f double dash means y2 at 0 point. So now we have to find out each value at 0 point. 0 point means when value of function we put x equal to 0. So first y at y0. Y0 is what? When we put tan 0. Tan 0 is 0. Next y10. When we put sec square x is 0. So cos 0 is 1. Similarly sec 0 is also 1. Next y2. Y2. We have to find out y20. So y20 is 2. y1 is 1 into y is 0. So this gives 0. Clear? So y20 is 0. Then y30 is 2. y2 is 0. So it already becomes 0. Plus y1 is 1. So 1 is square. So y30 is 2. Clear? Similarly, if you put here, then y3 is 2, but y0 is 0. So it's 0 plus y2 into y1. y2 is 0, so this also 0. And y1 is 1, but y0. So this terms is 0. y40 is also 0. Up to here it's sufficient. Now you substitute all value in your given equation. So when we substitute, I substitute here. Just you remember, I just rewrite all the values. y0 is 0, y10 is 1, y20 is 0, y30 is 2, y40 is again 0. These are all value at 0 point. Now we substitute in our Maclaurin series this. So y is our fx. Our fx is tan x. So tan x is equal to y0 is 0 plus x. y10 is 1 plus x square by factorial 2. y20 is 0 plus x3 upon factorial 3. y30 is 2 plus x4 by factorial 4. y40 is 0, and so on. Now you simplify it. See, tan x is equal to x. This terms terminate, this terms terminate, then plus 2 by factorial of 3 x3 plus x4 terms 0, and it goes. See, so what is our series? X plus 2 by factorial 3x cube plus 2 by factorial x. If we want to find out the fifth term, then it will comes like that. So this is one example for Maclaurin. First we have to find out all derivatives, then find out all derivatives at 0 point, and then substitute the value. You will definitely get the series. This is one case of Maclaurin. Similarly, we can solve many. You can find the many example of Maclaurins. You can easily expand. One more example. For example, if our function is y is equal to e to the power sine x. Same, we have to find out. Question is expand e to the power sine x with Maclaurin's theorem. So Maclaurin's theorem, always you think that our point 0 means we have to find out all value y1, y2, y3 at 0 point. When you substitute x equal to 0, you will get that. So now y1 e to the power sine x is e to the power sine x is cos of x. Again, when you put, you can see e to the power sine x is y. So this gives y cos x. y1 is y cos x. So it's easier. Again y2. y2 is u into v. Y derivative of y is y1 cos x as it is, plus y as it is derivative of cos x is minus of sin x. Clear? So it's very easy. At least y3, y4 up to 4-5 points you have to find out. Then find every value at y0. This is y0, y10, y20. Every value you have to find out at 0 point. Substitute in the series. You will get your required solution. Clear? Now I will show you one example of Taylor. Clear? So, how to expand our given series with the help of Taylor's. So question is, if log of 1 plus x is equal to x minus x square by 2 plus x cube by 3 plus minus 1 to the power n minus 1 xn upon n only. So this is our expansion of log 1 plus x. So here see, if we have to expand only log of x, then we use Maclaurin's. Now we find log of 1 plus x means a plus h. So in this case we use Taylor series definitely. So for Taylor series, first same you have to write Taylor series. What is f of a plus h is equal to f of a plus h f dash of a plus h square by factorial 2f double dash of a and so on. Now you write this in terms of y. So y a plus h is y, your a is 1, h is, so f of 1 plus h is x, f dash of 1 plus x square by factorial 2f double dash of 1 and so on. So now you write your Taylor series what you required in this question. So log of 1 plus x. A is 1, h is x. Now same like Maclaurin, you have to find out your function is log of what? Log of x. Your function is log of x. Okay, so we have to expand our function and then substitute the value. So I just remove this. Our function fx is, because it is f of a plus h, f of a plus, so function is, basic function is log x. When we find the value at a plus h, 1 point extra, then we write So f dash means this is y, this is y1. So y1 is 1 by x. Clear? Sum it y2. y2 is f double dash of x is what? Minus 1 by x square. And if you want y3, this is minus 2 upon x3 and so on. See yn, because it's so minus at n minus 1 upon x to the power n. Clear? And minus 1 to the power n minus 1 also, because minus is alternate. There have minus, this is minus minus plus, then minus plus minus plus. So this is general term. Now we have to substitute these values. But here at what point? X is equal to 1. We want the value of function at 1. So this log of 1. First is log of 1. Log 1 is 0. 1 by 1. X is 1. 1 by 1 is 1 by 1 is minus of 1. This is 2. This gives, so now I will write your values for each term. F of 1 is 0. F dash of 1 is 1. F double dash of 1 is minus 1. F triple dash of 1 is 2, and so on. Now you substitute here. Log of 1 plus x. F1 is 0. Plus x, f dash 1 is 1 only. Plus x square is minus of 1. Minus of 1 by factorial 2 is 2. F dash 1 is x square, f dash 1 is minus 1. Plus x cube by factorial 3. X cube by factorial 3. 3 means 2 into 3. And f triple dash is 2. So 2 will cut from here. So our series, what is our series? Seems to be x minus x square by 2 plus x cube by 3 minus x4 by 4 plus, means alternate plus minus sign and so on. So this is one example of Taylor series. Same, you have to find out the derivative, then you should concentrate what point we need to find out the value. Here point is 1 and it will be differ for Taylor case. If you want to find the given function expand in Maclaurins, then you use always point is 0. Maclaurin theorem or Maclaurin series always expanding given function at 0 point. Taylor means some different points. So this is one example of Taylor series. Similarly, you can see more example and solve it, then you can better understand how to solve these Taylor's and Maclaurin series. Thank you very much.